So we want to determine the number of moles in 28.117 grams of phosphoric acid. So we want to start with what we know. We have 28.117 grams of phosphoric acid. And we know that 1 mole of phosphoric acid is 97 .9952 grams of phosphoric acid. And grams of phosphoric acid cancel. And then when I simplify my expression, I have 28.117 divided by 97.9952. That's 0.287 moles of phosphoric acid, which is the final answer. So we're going to convert 0.179 grams of glucose to moles. 0.179 grams of C6H12O6. I know that 1 mole of glucose is 180.156 grams of glucose. So grams of glucose cancel. And when I put this into the calculator, I'm going to get something like 0.009935. To convert that to scientific notation, I'm going to move it 1, 2, 3, 4 places to the right. That becomes 9.94 times 10 to the minus 4 moles of glucose, which is my final answer. All right, so now we want to convert moles to grams. Again, we're going to start with what we know. We have 0.718 moles of sodium sulfate. 1 mole of sodium sulfate is 142.042 grams of sodium sulfate. Of course, we get that from periodic table. So now we simply need to multiply 0.718 by the molar mass. And I get 101.99 grams of sodium sulfate. So now let's dial up the intensity just a little bit here. Let's say that we have 0.180.156 grams of glucose, C6H12O6, and I want to know how many atoms, not atoms of carbon, not atoms of oxygen, okay, we had some technical difficulties, so we have 0.180156 grams of glucose. And I want to know how many atoms, total number of atoms I have with this much glucose. So again, I'm going to start with what I know. And I know that I have 180.156 grams of glucose. I'm going to abbreviate that as capital G in 1 mole of glucose. I know that 1 mole of glucose has an Avogadro's number of molecules. And I know that 1 molecule of glucose has 24 atoms of glucose. Moment. So when I simplify all of this, we get 1.45 times 10 to the 22nd atoms. That's our final answer.